All right. Hey. Hello, you. How are you doing? It's been a long time. Okay. In chat, please let me know if you can hear me. I'm assuming you can. And then I need to try one more thing. My Stream Deck is not working. Turns out I had to find it. I didn't know where it was. Oh, that was good times. I don't really see why you need to be authorized on Twitch anymore, but okay. You can do that, I guess. Let's try this one. RJ Helms. Uh-oh. I was wondering if you're going to be here, RJ. So, heads up, we're going to be editing your Apple IIe schematic. So, okay. Let's try one thing. No, that didn't work. Oh, shoot. Shoot. Okay. I don't know that's going to work today. I just realized my Stream Deck is completely set up to do the wrong... Yeah. Okay. In fact, I'm going to disconnect this right now because it's completely set up wrong. Okie dokie. Here we go. Squire, good to see you. Smalls, nice to see you. I am Butterfly. Haha, see, I'm using your Twitch names. Haha. Okay. Let's go to this guy and let's fire up. So we're going to be working on bit preserve. So here's the new plan. I'm going to give weekly streams a try again, but I'm going to focus on KiCad, and like code and stuff I can do at my desk, because then I don't have to rearrange the lab like every other day, which is one thing that was really killing me last time. So, all right, so we're going to do a branch. We're going to call this branch Apple IIe version 7. We'll do K7 because I want to get... So I've got this short-term plan. I want to get all of the schematics in BitPreserve, update it to KiCad 7, because some of them, I think, even have version 5 files, maybe. So I want to get them updated, and then I want to come up with a script that will package PDF versions of the schematics so that I can have a release, like a release that you download that's just a PDF of all of the schematics available. Because the repository is getting pretty darn big. And like, if all you want is one schematic, it's really big. I don't know how else to. So I don't know. I just got to thinking, like, wouldn't it be nice if there was like a release every quarter of here's the schematics or the PDFs as of today, and then maybe a version of the design files. I don't know. Oh crap. Okay, that wasn't open. Good. Also, this is controversial, but I'm going to play music in the background. So please let me know if that volume is too high or low. Because one thing I noticed with OBS a long time ago is the recorded volume is not the same as the streamed volume. So yeah, let me know if that's too much. Not rewritten. Yeah, right, Squire. Yeah, I don't know. There was lots of other things, but it was really the problem, and this is actually a good problem, is I have so much video work happening that I don't have time to be moving stuff around. And it was also the task swap of the video work I was doing and then trying to do stream work was like really bad. And so to me, this is my hobby, right? More of like hobby stuff that I want to do. And when I did the Apple IIc schematic, I did it entirely by myself, and it was very, very boring. All right, the schematic was made using older symbols. Some symbols may need to be linked to different symbol names. They can be rescued and put into a new library. So they want to rescue DB9 female. You know what we're gonna do? I don't want to rescue them. Because I think we can fix both of these. So I'm going to skip the rescue. And then let's see what happens. So then let's go ahead and just do a save. And then I'm going to actually commit that. Wow, all that. Okay, and we didn't do a rescue, right? And we don't have a backup file. Oh, the lock file, we don't want to... Actually, I want to get that out of here. We need to ignore this. Yeah. This repository only. Yeah. Okay. So we don't want the lock files. Oh, come on, really? Where does it want to put this git ignore? Oh, it's this one. Okay. Yeah, that's actually what we want. Okay. That's fine. I think. Wait. Did we have a git ignore in the root? Yes. Okay. This is it. Fine. Okay. We'll push those, and this will be the initial version 7 update commit, so we have something we can revert back to. Man, it's taking like 15 minutes for us to even start KiCadding. KiCadding? Is that a verb? Okie dokie. Are lock files new in version 7? Yeah, they are. And I know from experience that they are not very Dropbox friendly, but yeah, I almost want to say they weren't even part of like the initial 7 release. So I don't know. All right, so I would just want to do this so that these stand out more. sheet cannot contain. Okay. Well, what? Whatever. I don't understand how was it working if it can't have IO2. I feel like this is going to break something, renaming all of these. Yeah. Yeah, actually, I didn't even realize. You know what? Now that I said that, RJ, they had to have changed after the version 7 release, because I think I did the Game Gear schematic in version 7 and I never had a lock. Unless I did it in 6 and I just don't remember. Huh. Alright. For no obvious reason, I am changing. I was just making the blocks a different color because I want them to stand out. I don't know. I guess I should have a reason for doing stuff like that, but I don't. And then I wanted to do a revision 2 here, just so that... Okay. So, okay, step 1 was update this for version 7. That's the easiest thing. But here's the thing. I did this on the 2GS and the 2C schematics that I drew, and I was shocked when I did the ERC check because there were lots of problems. And so initially I thought, I don't care. And then as I've gotten a little bit more familiar with ERC stuff, I've decided I do care. So we're just going to take a little bit of time and update these to update the symbols and stuff so that they're correct. All right, what is this complaining? Now this is complaining that the symbol library is legacy. Okay. And I think we can do a migrate libraries here. Okay. That might be another commit just in case. Oh yeah. Let's commit that. In fact, I'm going to... Yeah, we'll just do it all. Hey, Francois. All right, let's do that. So we have another backup point. Okay, so now let's open up the 6502. So originally I thought, hey, you know what? It's still September. I should do a Tandy schematic. And then it's like, well, the only one that I really want to do is the Model 100, which I got from somebody else as a submodule. And so there's not really much we can change there. And then I thought, okay, well, maybe we'll do one I haven't done before, like... So the green screen is not... Green screen. Why you gotta embarrass me like that? Still don't like that. Still, oh wait, that's the other side. Oh. Why not? You know what? I bet it's when I messed with the green screen settings. I probably did not. I was trying, so I have yellow on my shirt and I was trying to get rid of the, I was trying to prevent it from keying it. Render delay. What? Do 410. Let's try that. Ugh, that's driving me. I don't like that. No, you're not supposed to do that. That's too much. That's, maybe I'll go to there. All right, if this doesn't work, I'm just gonna leave it and we'll just deal with it. Okay. The only other thing I can do is, screw it. Okay, that's enough. KiCad, oh. That would, I think, open source firmware for KiCad would be nice. I have a Cameo silhouette. I really like it. All right. Anyway. I see the... I just don't understand why it's actually buzzing on me. That's about as good as I'm going to get it today. I got to figure that one out. I wonder if it's because that light moved. I moved that light a long time ago. Okay, so first up, power input. So VCC and ground are both power inputs, which can be a little confusing because you might think of ground as a power output. But what these are saying is this symbol accepts power from somewhere else. And so they're inputs. So like on a voltage regulator, you would have power input on the input pin and power output on the output pin. So yeah, so even though you might think one of them is supposed to be output because power and ground, it's not. They're both inputs on a device. Phase 0 or faux is an input. Sync is trying to remember. I think sync is an output, right? Because this is this tells you when the opcode being right. This is the one. I think this is the one that actually tells you when the opcode being decoded, or what is it? What am I trying to say? That when it's decoding an opcode, so that if you look at the data bus and you see an opcode hex value, you know that it's actually an opcode. So let's see now. Address. Okay, so now what I'm going to do is I'm going to go into the pin table, which is what I probably should have done in the first place because it's a little bit easier. So address is going to be output because microcontrollers are very bossy. They always tell everything where to go. I could have done copy. You know what? Because I just love showing it off. We're going to do copy and paste on data bus because I should have done it already. No, you know what? I don't want... Okay, I changed my mind because I don't want to mess up the position of any of these pins since that's not what I want to do. All right, so data will be bidirectional. No. I think these need to be tri-state because I think these should be able to go into a tri-state, right? Okay. Read write is an output, faux is an input, reset is an input. All right. Let's go back up to, let's see, ready is ready I think is an input, right? Because you pull ready down and, or am I thinking this wrong? Yeah, isn't it? You pull ready down. Yeah, because like in the Apple II, a card can pull ready down and that holds the processor. So that's an input. Interrupt is an input. Non-maskable interrupt is an input. Sync is an output. Okay. I think that's right. If you guys disagree, let me know. But I think that's what the 6502 looks like in terms of its actual pins. All right, let's save that one. Oh, you know what I should have done? Oh, well. I have the Apple IIe hardware reference downstairs. I should have brought that up here with me. Oh, well. Ozabawelba. I don't know what that noise was. Okay. Let's move on. Let's do the LS224. Okay. Yeah, I don't actually remember either, Arjun. So let's just do WDC 65 CO2 datasheet and double check it. Oh, that's another good point. Maybe that's part of the confusion. Ready is on page 10. Ready says logic level low will halt the processor. Returning ready. Bidirectional signal allows one cycle. Okay. Yeah, it's just because of the way that the Apple II, the rest of the schematic got laid out. Is ready bidirectional on anything other than on 6502 or just 65CO2? Yeah, this is what I think. Good call, RJ. Okay, so it is an input on the 6502. Now my question is it only the WDC 65CO2 or is it bidirectional on all 65CO2s? For example, if you did a enhanced 2C or 2E or on the 2C. Okay, well, I tell you what, it doesn't really matter because this schematic is for an unenhanced 2E, so it is an input only on this one. Okay, moving on. Let's edit LS244. We'll do library symbol because it is in this library. Okay. Can you? Oh, I can't turn layers off in this one. That's lame. Okay. So output enable, those are both. Okay. What's the 244? Isn't this a buffer? Yeah. Octal buffer. And it's one direction, right? So this symbol is already correct. Yeah, because you've got in and then out. Because the 244 is one direction, 245 is bidirectional, right? You didn't draw the power pins. Okay. I mean, I'm less concerned about that in terms of, well, yeah. Yeah, I see what you mean. Like, they don't... Okay, I see. You made a note about that. Okay. I think my response is going to be, we're just going to leave it. I'm not going to make that change unless, there's the real question. Unless E or C gives us an issue. Okay, I'm going to skip the MMU for the moment because basically what I want to do when I get to for the MMU and the IOU, I need to open up the 2C schematic because I've already figured out in that one what all of the signals are because it wasn't obvious. It was a lot more difficult than I thought it was going to be. All right, so let's do the memory, which should be pretty easy, right? Let's just go to the symbol table. So refresh. So what is D and Q? I mean, Q is probably tri-state, right? Did you have a datasheet defined for these? No? Okay. Okay. What the heck is D? Maybe I can tell by this diagram. Yeah, I'm actually, in retrospect, I'm really glad I'm doing this on a computer I'm more familiar with, because otherwise we'd be looking up like every single signal, which will be kind of fun at some point. But okay, so D is data in, Q is data out. Okay. Are they connected together in the schematic? Yeah, okay. All right. I am also still going to assume the output is tristatable, right? Because isn't there like a... I guess I could look at that diagram again. I mean, it's got to be, right? Because it's on the data bus. Yeah, it's got to be. I don't see how it couldn't be. All right, so let's go back to our pin table. So refresh input, D is an input, write is an input, RAS is an input, address are inputs, VCC is a power input, address are all inputs. Q I'm naming tri-state because it should be tri-statable. CAS is an input, and then VSS or ground is a power input. Hooray. So let's save that. Exit this. You know what I'm going to do too is, not that the NTE datasheet is the best option for this, but let's go ahead and define this one as that, just so that we have it. Is there a specific name for where it's not fully tri-state, but output? God, I can't read that. Why does YouTube put something right on top of chat messages that you don't need? I'm gonna guess you said or high impedance. I mean, if a pin goes high impedance, it's still tri-state, right? Oh, I get your point. Yeah, because it's not truly tri-state. Yeah, it can't be tri-state because it can never be input. Yeah, that's a good question. I don't know if there's like bi-state or just high Z. Yeah, I guess I never thought about that, or I didn't like right now. Okay, so now what I wonder is if I do update symbol, update symbols matching this value, we should just be able to do just those two things. And then all of the memory chips should now be updated. So let's do a save. Okay, let's go check out the ROMs. All right, so let's get into our fancy table. And VPP is an input, even though I really wanted to make that a power. Addresses will stay inputs. VSS is a power input. Chip enable, okay, data. I wish I could like, no. Okay, that's not terrible. I'm just double clicking, pressing B, and then selecting it. So wait, here's D0. I do wish you could highlight multiple and then just select, and let me try this again actually. Yeah. No. Okay. Chip enable, output enable. Oh, wait. Data is tri-state. Did it again. Oh, you don't have to double click. Okay, that's actually not too bad. I'm gonna ask or I guess I'll look later in the KiCad forums and see if anybody else has brought that up. That it almost seems like there should be another pin type that is high Z. since it can't ever be an input. I guess it doesn't. Does it matter though? Maybe it just doesn't matter from a rules check. I don't know. All right, NC is a no connect. Now, I did learn in the KLC, the KiCad library conventions, no connect pins should be hidden unless there is a situation where you would connect them. Like, for example, if the datasheet says no connect or tie this pin high for ESD or not ESD, what's the like EMI. Jeez. Okay. Power input. Okay, so hey XOT, micro hobbyist. Okay, so addresses are inputs, data is our tri-state, VPP is an input, no connect is unconnected, power input, or P is probably program or something like, or the right. Chip enable, output enable, and power input. Sweet. Okay, this guy looks good. High low, high Z. Oh. Yeah. Duh. Duh. Duh, 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 duh. Yeah, see, I knew that. I just wanted to let somebody in chat come up with the answer too. Yeah, that's what I was doing. Okay. Uh-huh. Why is this complaining? Okay, unplaced units, we'll deal with those later. That might actually be okay. Why is this one complaining? Input not driven by any output. Okay, that should probably be fixed now, but I'm not going to rerun ERC for a little while. Okay, MMU. Let's see. How's going to be a good way to do this? Whoa, that is not a good way to do that. Crap. Great. Oh, Windows. I just don't think you could be any more terrible. Okay, so we're going to load that. Now I'm going to load a new... Oh, not KiCad 6. Heck no. Shoot. I didn't even know I still had that installed. I'm going to open up this one. Then we're going to open project. And we're going to go into... projects, GitHub, preserve, Apple 2E, no, James. You're opening up the 2C schematic because you want to go look at how you did the MMU before. So that's the IOU MMU. Okay, so let's edit this one in its library. Now, I know somebody's going to say, well, why doesn't the 2C and the 2E share a library? So that because the parts are the same. Because they're not. That's why. Yeah, I don't know. That was like, I feel like that was a debate we had a long time ago. And I personally decided it's better to just leave, even if two models of computers share parts, I would rather have two separate libraries. And I know it just, to me, it makes more sense because there could be differences. And so anyway, now this is where it gets frustrating because we're going to duplicate effort, but tough. Now we just deal with what we decided already. Actually, you know, now that I said that, I'm just going to totally backpedal and say it totally makes sense, like in this case, because the schematics were laid out completely different between the E and the C, and so it'd be really hard to share the symbols and have schematics that looked like the original. There. Solved it. Moving on. Okay, so let's, ground is easy. That's a power input. Address, I don't know what 3, 4, and 5 were. You know what would probably be easier is what if I open up this table and then I could just like literally just copy and paste. So 3 was the clock. So power input, 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 input. I guess in the 2E schematic, they must not have labeled those. Okay, so this is going to be output. All right, RJ, have a good one. Thanks. Yeah, another reason I was unopposed, or I was opposed to sharing the library, is because KiCad is not exactly collaboration friendly. And so I was like, you know what? It's probably just going to be easier on everybody if we don't try to do that. And that's not really, I don't mean that as a knock. I mean, it is what it is though. And it's something that I think the developers are very actively aware of. I think they all, you know, anyone that says, well, why doesn't it support Git better? Well, everyone that develops on KiCad already feels that pain. Okay, there we go. That was easy. Yeah, Squire. Yeah, I think, actually, I mean, I think this is a really good example of it. I just, you know, in a project like this where the goal is to recreate existing schematics, I think the shared library approach made less sense. Now that said, I think in most cases, when I did the 2C schematic, I probably started with RJ's, like I used his MMU symbol instead of just creating mine completely from scratch. I don't remember exactly what I did, but I feel like there was like some, you know, I was still able to leverage some of the work without having to recreate everything. So, but okay. So CPU page, for the most part, I think we're good there. So let's move on to, which one is this? This is the IO page. So there should be an IOU in here. What I'd really like to do is let's get that done now. No, IOU is not on this page, but the timing generator is, isn't it? No, it's not either. Really? Okay. I find that suspicious. Okay, let's go take a look at the keyboard controller, which is literally a 6502 with a masked custom ROM. All right, so I ended up, okay, so let's do this way. I don't want to, oh wait, I know what I can do. See you later. Smalls, thanks for coming by. Okay, so why? We're going to start here, and this is going to be a, what did I call them? Passive? Yeah. So I did these as passive just because the way that, because this is part of the keyboard matrix, and they get switched between input, output. I guess for that reason, I decided to make them passive. I guess they could just be bidirectional, but I don't know if that, I didn't feel like that accurately describes them. Okay, so what's delay is input, any key down, which is pin 5, is an output. And keyboard strobe, which is pin 16, is an output. We'll come back to VDD. All right, and then these are outputs. This is, you could probably argue that these are tri-state, but they never get tri-stated because the keyboard controller connects to an EEPROM and it drives the address of the EEPROM at all times. Joe's Computer Museum does. I wonder if that's the one I bought because let's see, I guess it was 2 years ago. We were repairing an Apple IIe keyboard that was a nightmare. Every single, it was completely random if I would replace a key switch, whether it would work or not. Or I would replace one that wasn't working, it would start to work, and it would work, and then another one would fail. And so I ended up buying a recreated keyboard controller, but I don't remember what it's called or who it was from. I didn't end up using it, so. Okay, let's get the powers. Now where's the others? So there should be, so 27, 30, and 15. Okay, let's take a look at that symbol. So we've got passives over here, inputs for shift and control. Those are literally the shift and control keys on the keyboard. VDD, which is probably, it's funny, this symbol uses VCC and VDD. I always think that's funny. So that's defined, that's defined. That's in power input, power input, power input. Delay, I don't remember what delay does. I don't know if that's like a in-key rollover thing. JCM1. Let me go do a really quick check. No, I don't think I bought that one. Okay. So, I'm happy with this. We're going to go with it. Let's move on. Item number next. 2716. This is the keyboard ROM. So the really cool thing, if you don't know how the Apple II keyboard works, is so you've got this microcontroller, which is literally, it's a 6502. It scans the keyboard matrix and tries to figure out which keys are being pressed down. And then based on the keys that are pressed, it outputs a, I was going to say 8, but I guess it's 9-bit value to represent the key, which is actually the address of, or the address lines of a ROM. And then when you hit the soft switch C000 or C010, that soft switch will enable the ROM to output an ASCII code onto the data bus. And so this is how you could map different keyboards to different characters, because you would replace this ROM. So I don't know. I think it's pretty cool. It's not at all how I would have thought the keyboard worked until I actually looked into it. Like, it was not what I expected. I was like, holy cow. Bipolar on the high side, FETs on the bottom. Yeah. You know, the B pens aren't in order. Oh, actually, that doesn't matter at all. It's well, yeah, for the most part, it doesn't actually matter because they're just address pins for the EEPROM. And so as long as its bits line up with what's in the EEPROM, or I keep saying EEPROM, it's not an EEPROM, it's a masked ROM, so the ROM chip. So yeah, it's actually pretty common that your address lines don't necessarily line up the way, well, I shouldn't say it that way. I'm not going to say it that way. But yeah, I don't think they're in order. And it's probably something to do with the way that the keyboard controller outputs its values. So, because if you look at the ROM contents are in ASCII order, and so my guess is the keyboard controller, it doesn't line up the same way, so they probably reordered the bits so that it lines up. that makes sense. I don't know if that makes sense. Okay, so these are all going to be tri-state. BCC is power input. VPP, well, it's an input, but I don't think it's connected. Anyway, output enable, address, chip enable, and then all the address lines. Okay. That looks good to me. Okay. Let's move on. Okie dokie. Let's see. So oscillator. Oh, this one drove me insane on the 2C. All right. So these are 1 is a power input, 3 is a power input, and then I'm not sure which one is the input and output. So 4. Actually, this doesn't even matter because I don't think this is actually populated on a 2E. I think the way this works is yeah, okay, never mind. This is not an oscillator. This was a filter, and this filter is not even populated on the 2E. But that, okay, doesn't matter. 4 is an input, 2 is the output. I remember now because I remember RJ and I were trying to figure this out. And if you go look at the 2E, this is the footprint is there, but it's not populated. However, it might be on the 2C. I'm not totally sure. Doesn't matter. Okie dokie. Oh, what did I just do? All right, so I'll take a look at the 245, but my guess is he probably used the symbols that were, yeah. So that direction, chip enable, and then the rest are tri-state. So that makes sense. Because I think for the 7400 series stuff, he just used what was already in KiCad and then just adapted it. So what is this pin style? Oh, that's nice. Output low. Well, we're not gonna get that technical. In E558, this is the four timer version of the 555, which you cannot buy anymore. So sad. So sad. All right. Let's see. I probably already figured these out. Huh, no. Are you kidding me? Does the... Oh, no way. No. It doesn't use a 558? Then how does it do its game port? Huh. That doesn't make sense. How does this not have a 558? Okay. That's a mystery for another time. Alright. I've probably already figured that out at some point. I just don't remember. Out. Reset is that a input? Yeah. And then timer, or is this timer? No, this is trig. These are the triggers. This is the that's the thresholds. I'm just looking at my other symbol. Pin 4. Nope. Reset triggers. These don't feel right. Yeah, we'll go with that. Okay. Yeah, so the 558 anyway. What I was getting stuck on is that the 558 is used by the game port to tell the paddle where the paddles are at. Because you basically you hit each of the timers, and then you see how long it takes for it to reset. So, oh, the 2C only. Okay, that's why. Hey, Gustavo, good to see you. It's been a very long time. Although I do see you pop up on Instagram and that other site. I don't even know what to call it anymore. It's good to see you. Okay. Yeah. So it only has the one. Yeah, I think what was throwing me off is because even the 2GS has a 558. Pretty sure it has a 558 because I think that's where I got one of mine from. All right, so that symbol looks pretty good. Multiplexer. I do want to come back and look at these resistor packs to make sure that they're all used correctly, but looks like he did. So I'm not going to worry too much. All right, so we got that chip, this filter, and then the rest of this glue logic is probably okay. What is this error up here? So I'm going to try to click on the symbol. Input has input power pins and units that are not placed. Yeah, okay. Well, I'm not going to worry about that probably tonight, but we got to figure something out about that. Okay. We'll just keep going. So 373, one of those things. This oscillator looks suspicious to me. Yeah, so let's see. 1 and 2 are power inputs because they're connected to ground. Shoot. It could just be... Are these oscillators or are these crystals? Well, okay, they're oscillators. So what this is actually, 2 is an input. Because I think it's the enable signal. Because 4 and 1 are the power symbols. And then 3 is the output. All right, because the 2C didn't have the dip, did it? It just had the port on the back. That's why. All right, I'm making a couple of broad assumptions here, but I think these are fair. I'm pretty sure these are oscillators. I'm not entirely certain why they have 2 unless this is to represent like PAL. And what the heck's this for? Okay, because I'm guessing these are for like PAL and NTSC, but why wouldn't you just have one footprint? Whatever. Let's take a look at this guy. Input, output. Okay, this doesn't have power symbols. It does. Oh, a separate symbol. Okay. I'm gonna worry about that. Translating ZX Spectrum basic manual. Nice. Oh, nice. Yeah, I bet that'll be really helpful for some people. So when you say that, like the Commodore 64 manual, do you mean like the actual user's manual that has all the programming examples and stuff in it? Because that's a really nice manual. The VIC-20 is a little bit nicer, but the C64 had a lot of good information in it. Why can't I change? Oh, there we go. All right, let's move on to the IOU, or the IO controller unit, input-output unit. Yeah, that's right. He didn't name any of the pin because RJ Helms, he actually did this 2E schematic, and I am so glad he did, because during the Mega 2 project, I ended up using it extensively. And but he, like most people, he copied exactly how the schematic was originally done, which is frustrating because it's exactly like this. It has a block for the IOU, and then all of the signals are named. And so, like when I did the 2C schematic, the 2C schematic is drawn differently, and so I did it different. But yeah, talk about, I don't like this. I don't like this, but I'm not making the effort to change it. It's just fine the way it is. So we'll do the same thing. I'll just open up the pin table, because the pin numbers should match. Now the IOU is slightly different between the 2E and the 2C, but it's only one pin that's different, I think. It's the cassette interface got repurposed in the 2C. Since the 2C doesn't have a cassette interface, that pin is now it does the bank switching between the two ROM banks. Yeah, so like pin 7 is, I wonder why I marked it as passive. Yeah, scans of scans. Yeah, when I first started doing this project many years ago, a lot of people were like, well, why don't you just use computer vision and have it do it for you? And it's like, well, I was like, okay, regardless, I still have to do at least one of them, so I know how I'm going to write a program to do it. And, oh, there is no pin 16 on this one. That's interesting. Okay. And as I did that, I realized I can barely read these. How is a Python program going to? And so, you know, the reality is a lot of these scan schematics are barely readable. That's like, for example, on the 2G, the 2GS schematic, which I based the Mega 2 on, the Mega 2E on. For months, I thought that one of the signals was RC ROM. No, it was RC MEN, and I could not figure out what RC MEN stood for. And one day, it hit me that it was an O, and it was RO MEN, so ROM enable. But on the scan of the schematic that I had, it clearly looked like a C. And it's like, okay, well, even if I wrote a program to go and do all this, I'd have to go back and recheck it all. It'd be a nightmare. So this doesn't have the IRQ pen. I feel like that's suspicious. That's very, very suspicious. I actually have this book. It's funny because I've got all of the hardware reference manuals now from the Apple II to the 2GS, and it's interesting to me how as you go through each one of them, they get less and less useful. But there's also a lot of stuff that's just copy pasted from one to the next. So trying to think. So if we go look at the index, what are you doing? Why can't I? And I want to know where this should have the IOU pinout. We're doing the IOU, right? Right. I'm in IOU, and I think it's on page 187. So let's see. There's an offset of about 30. So let's just do 157. Nope. 210. That gets me pretty close. I'll recognize it when I see it. I might have passed it. I did not recognize it when I saw it. Yeah, about that. Yeah, it should be... Oh, I see. There, it doesn't mention it here. That's not what I'm looking for. You know what? It doesn't matter. I think I'm overthinking this. Yeah, this is the tables I was looking for. Right here. Oh, interesting. So in the 2C, pin 16 is IRQ, and in the 2E, it's a no connect. So IRQ is not connected. Huh. All right. Okay, so now there's two differences I know of between the two chips. Okay. That's not the one I want. What about this one? There we go. All right, so it's really hard to compare these now. Oh, shoot. I should not have put those there, but I don't want to change it in here. I'll have to make a note to fix that later. These no connect should be inside of the symbol so that they don't get accidentally connected. Okay. Save. That's good. This is one I don't want to do. The HAL, or basically the timing generator. These, for whatever reason, on the 2C really messed with me. I thought these were all outputs, and it turned out a lot of these things were inputs. So, but they're not named, are they? Shoot. Okay, here's what I'm gonna do. I'm gonna move this over to here. I'm gonna open up this, and we're gonna do this as 3. So vid 7 goes to pin 5. Vid 7 over here is pin 13. Okay. I'm going to assume, nope, they are not the same thing. Are you kidding me? Ah, stop it. What are you doing? Ugh, this is a mess. This is such a mess. Okay, so vid 7M, so this is the 7 megahertz clock. The load the shift register, PRAS and PCAS, Q3, bidirectional, nice. Phase 1, phase 0. Okay. This one get dumped already? What do you mean by dumped? You mean like the ROMs? If you mean the ROMs, then yeah. All of the Apple stuff, pretty much every version of every Apple II there's a binary for it. I don't think there's any that are missing, other than maybe What am I trying to say? Oh, I just realized this. These are labeled in and out. So it's pretty easy to tell which direction these go. Prototypes is what I was trying to think of. There's some prototype stuff that's not. Don't. Input, CP, input. So, and then this one doesn't have power symbols. Okay. Well, that was a lot easier than I thought it was going to be. Oh, these are not pals. Okay. Yeah, this is actually not a programmable array. These are, so first, it wouldn't really be interesting because these are basically just all shift registers to divide. It's just a clock divider, and so I think this was an uncommitted logic, but it's not programmable. They're all masked. So I don't. In fact, I wonder if the manual even says why they're called, because like in the 2C, it's a completely different name. But yeah, it's not a. It may have been prototyped as a PAL, but they're masked chips. And I'm pretty sure. I mean, they're trying to recreate them would not be very difficult because they're basically just shift registers. I mean, one thing you have to remember with when you go from the Apple II to the 2 and 2 Plus to the 2E and the 2C is every custom so the 2 and the 2 Plus have no custom chips other than the ROMs. Everything else in them, and the keyboard controller to some extent, everything else in them is off-the-shelf logic chips. And so when you look at the 2E and the 2C, all of the ASICs are just re-implementations of those logic chips. So even if you couldn't, yeah, see, they're calling it a programmed array logic, not a programmable array logic. So, but yeah, anyway, they're masked. So. Yeah, I think they just changed the name on the 2C just so that maybe to even confuse people. But TMG is, timing generator, so it makes more sense than HAL or PAL. But anyway, it also would take very little to. Well, actually, I don't know. I mean, there's no pins on these that would let you. I mean, you could just do it through a vector table, but like I said, there's nothing super interesting because it's all well documented somewhere else anyway. So, oh my God, did I really just do that? Yeah, that was dumb. That was super dumb. Oh, I need to get my buttons fixed. So I should have wanted to do the facepalm graphic. Out. And the rest are inputs. Okay. Okie dokie. Chip. IOU did 2732, the character ROM. I don't think we did that one yet, but this might be based on. Nope. All right, so let's go. Outputs are going to be tri-state because it's a ROM, so there's a chip enable. I don't know what 12 is. Let's see. 12 is probably one of the address lines. It's just hanging out there doing nothing. Okay. 21 well, let's see. 24 is going to be VCC. And where's ground going to be then? It's probably 12. Right? Yeah. And then 21 is probably an enable. 22 is an enable. Oh, whoops. So 19, okay, those are both addresses, which they're probably tied low. 18 was an enable. Tag that one. Yep. 21 is probably like a programming pin. I don't remember the pinouts of EEPROMs or ROMs. Okay. Let's save this guy. What I was going to look at is, so 12 is grounded, so that's probably some form of input, graphics signal, segment A, segment B. Not sure what VC is. Don't remember. That's power, and then, oh, duh, 12 was ground. Duh. Okay. Okay, got it. It was 22. What else was? Okay, 24, 18. Got it. Now I see what's going on. Okay. That one is good. That's glue logic, glue logic. I think this is the... Oh, is this the hybrid? I'm gonna have to make some guesses on this one. Video amp. Okay. If you say so. So this is probably a power input. This looks like a power input. This might be a power input. It's going to ground, so we'll say it is. Oh, so the somebody did dump it. Interesting. Interesting. So let's see. Where is our shift register? So 5 is an input, 2 is an output, 3 or is 2 an input? I don't know what, you know, what's bothering me is I don't know what this thing is doing. $68 HC05. Oh, you silly 6,800 users. Just kidding. I cannot read this well enough to understand. So, because this looks like it outputs to here. So then this is amping that, and then this is another amp. So I actually changed my mind. This is clearly an input. And then it's getting the sync signal. Oh, so then that question is, who's creating the sync pulse? IOU does. Yeah. And then the color gate. Oh, that's not color gate. Oh, that's the color burst. 7's getting the color burst. Huh. So I wonder if this is actually, so because this is clearly the shift register output. So this is the luminance information. Here's our sync pulse, the color burst. Ah. Huh. I wish I knew what was inside of this box. I wonder if the manual has this. Our supply, no. Okay, let's try this one down here. Video output signals. That's not quite what I want. But we can go try that. Yeah, okay. Let's go see what page 186 has. No, ground video. So let me think. Maybe pin 2 is an output. And then pin 3 might be an output as well, because pin 3 may actually, maybe that's yanking the signal down for the sync pulse. And then maybe pin 2 outputs the color burst. And then when all that's done, then the luminance gets put out. It's kind of what I'm thinking it's doing. Is pin 2 is probably, I'm just trying to think why you would do it this way, but I mean, pin 3 looks like it wants to yank the signal down, so that's why I'm thinking this generates the pulse, the sync. And then since the color gate color burst comes in through here as well. Yeah, that's what I'm actually thinking. This is maybe this is the composite signal. 5 is the luminance information. Okay, I'm gonna leave it like this for now. I don't. You know what I'm gonna do? I'm just going to go and look at this on a scope and be done with it. So we'll just do it this for now. You think that's the modulator? I don't think so, because the Apple IIe doesn't have a modulator built in. Unless... What if this is for Euro? What if this is for the Euro Apple? Okay. You know what? Because I'm not... This is where I wish I was better at... I wish I was better at being able to decode what was going on in the rest of the stuff. But this is just bothering me because this is literally a black box, so I don't know what this is doing. Like, I would feel better if I knew what this was doing. So I'm just gonna go look at a real Apple IIe and figure it out. So we'll hold off on that one. That might be this might be a good one to go and scope out and see because now I'm kind of curious why, because what's throwing me off here is why would this box get the same signal that basically, it's like, why is this signal coming into the box twice? That's bothering me. So anyway, I'll go look it up. I'll go look at a real one. Okay, so I think timing and video is probably in good shape. Let's move on. Oh, this is super easy, right? The slot. Just kidding. I guess technically we can just leave the slot all passive. Because, yeah. Okay, I just almost said something really dumb. I almost said, well, I wondered what I did on the 2C schematic. For those that know the Apple IIc, that is a very dumb statement. The 2GS, however, I did... Oh, what's going on? Pin 2 is summed with the color burst. Oh, yeah, you're saying it's getting... Because Q1 is summing the two? Okay. Okay. What's going on? Why is this instance locked up? Cancel. I will save this though, because something's wrong. So let's X out of this instance. I wonder if there... Oh my goodness. There was a dialog stuck open. Okay. Let's get the 2E back up. It'll come into the slot. All right, so then we'll go back to this other instance and I'll open up this schematic. Oh, this one's not updated either? Oh, we should have started with this one because I know who made this one. All right, slot maker. And then what did I do on the slots? Rescue symbol not found. That's fine. Okay, I left them all passive. I think we're just gonna leave them passive because they are slots. So, or they're connectors, so why not? One thing I want to do real quick though is I want to get rid of the 2GS files that just got created because I don't want to contaminate this branch. I want this branch to just stay for the 2E. Okay. So that's a socket, that's a socket. This is a pin header. This should all be passive, right? Yep. Okay. Well, this one's not so bad. Yeah, because this is all sockets. Or what's the word I'm trying to say? Interconnects. Oh, okay. So I think that's the majority of what we want it to change. So now let's run E or C again and see what happens. Look at you using Git. Yeah, it's kind of scary how much better I've gotten at Git. Okay, so input pin not driven by any outputs. Best, I'm going to do a video on just this error message because so many people get messed up with this. So what we got to do is we got to tell KiCad where does power come from? And power comes from these pins right here. Specifically these over here. So what we need to do is I need to extend this out a little bit because we're going to add... Okay, I tell you what. Let me commit this much. I don't trust why I did that. That's okay. All right, let's go ahead and do that. And now I want to know. Okay, now what we're going to do is let's get our power pins driven. So we'll add a power flag. Oh my god, why is this slow? Oh, why is it loading footprints? What? Whatever. So we want a power flag. And oh, you know what we can do is we can just put it like right there. That'll work. And then I don't have to move everything over. Because here's what I'm going to do. And I need to change this because I always change that for screenshots. That's much better. We're going to... I'm just going to slap that guy right there. And we're going to hide this because we don't really need that information. We're going to say we're going to drive on all of these. All right. Ooh, this one's going to be really tight. How do I want to do this? Move everything down. All right, so I'll use the G so we can move all this stuff down. Whoops, I didn't want to grab ground. I want it to grab this stuff, not this. Unselect. All right, let's move this down as much as we can. Because then I want to grab these and move them down after I put a flag down here. Right? Right. Ooh, that looks wrong. Okay. Now let's get that marked there. Let's go ahead and move this down. These. Oh, what are you doing? Down here. All right. Put that there. All that because I wanted to move this down as much as I could. Nice. Let's move that to about there. This to here. And then this stuff to here. All right. There. Look at that. Hey, Francois. If you're going to bed, good night. If not, cool. Stick around. Okay. So now, everything, all the power rails, if these are the only power rails, should all be driven with a flag now. Because we've told oh, there's one more. We got to tell it. Over here, this is where ground comes in. So we have said these are, so I like to put the flag, so some people just put the flags wherever. I like to put the flags on whatever is actually providing power. So these are like the sources for power. So I put the flags here, and then that way now these should drive all of the power input pins. So let's see what DRC says. Input pin, not driven by output. Okay, that's good. That's fine. We'll get to that one. I'm looking for the power flag. I don't like how often that's coming up. Jeez. Unplaced units. Has input power pins that are not placed. Okay, those we know about. Input pin not driven by output. That's okay. Okay, so I think, input power pin not driven by any output power. What? So negative 5 volts doesn't have, but these are the burn-in pads, so this is actually an input, isn't it? Oh, because negative 5C is different than the others. Interesting. Okay, whatever. I don't care. All right, now I want to go and address some of these. I want to do this one next. CP small is not found in the symbol library. Okay. So let's go clean that one up because that's an easy one. We'll go into the tools, edit symbol fields. And then in this one, I want to group by, yeah, reference is fine. Oh, I thought I could. Oh, this is not the table I want. This is not the table we're looking for. Shoot. I was hoping, okay, what we got to do is we'll edit this symbol. We're going to do change symbol. I want to change anything that matches, change symbols matching identifier CP small, because those are now going to become, I think they're C polarized small. C pol, no, C polarized. Isn't there a C polarized small? There it is. C polarized small. So this was a change, I think in version 6, maybe, that they changed, for some reason they changed the small name. Okay, that's fine. All right, that's a big update. So that should get rid of a bunch of, let's see, 3725. So it got rid of a bunch of warnings. Fine. I was hoping for better than that, but okay. MMU has been modified in the library. Okay. So let's do update symbol. I think I'm just going to do, yeah, we'll just update all. What error did we just get? Symbol not found. J8. Okay. What is J8? So the symbol you're using was not found, huh? That seems suspicious. So connector DB9. Oh, they changed the name. That's why. Uh-huh. Uh-huh. Okay. Also, they fixed the identifier. It is a DE9, not a DB9, because DB means it would be big enough for 25 pins. So we'll just change that one. And that shouldn't... Oh, I can't tell. Did that actually... 5, 4... Okay. That didn't change anything. Good. All right. Okay, so you're not seeing a VA1 anywhere. I wonder if maybe it was the option for the modulator for Euro apples. Because I think there is a header pin around the RCA jack that you could connect something external. Or at least on the 2 Plus motherboard, there is one. I don't know. I can't remember. I do not remember. Okay. Now let's see. We're down to 11 errors and 6 warnings, which is interesting because we didn't... Oh, I did update all symbols, so that might be why some of the errors went down. All right, well, let's focus on errors for the moment. So pins of output and output are connected. Okay. Yeah. Oh, yeah? Where are you at? We're at UE4. So let's zoom in. UE4 and UD1. Yeah, so PRAS is definitely, it's supposed to be an output from here, which now makes sense. Now this makes a little more sense since now that I realize that this is a programmable array. That's why these are just clearly identified as input and output and then the clock. Anyway, I wish I had realized that when I was doing the 2C schematic, because it took me a long time to figure out which way the signals were going. So on the MMU, PRAS must be an input, which I think I had trouble with on the 2C schematic. I tell you what, let's go look at the, I'll bet I probably, so let's see, ROM, PAL, IOU, MMU, PRAS, memory row address strobe. So why would that be an output from? Yeah, it's the RAM row address strobe. Oh, it's RAS. So that's for the refresh. Alternate video amplifier? Okay. Interesting. Okay. So if this is an input to the MMU, okay, so the timing generator is what actually generates this PRAS. So my guess is that was meant for the DRAM refresh. So the MMU must be accepting it as, hey, it's time to do this. Wow. I have a hard time believing that that's how that works, but this is one of those signals where I think I thought of going onto an actual computer with 2 scope probes and look to see which one rises first so I could figure out who is the driver. That might actually be, I might actually do that because I ran into this same quandary when I was working on the 2C schematic, because a couple of these signals, it's not clear to me which way they're running. But knowing that that chip probably has, I mean, okay, I'm gonna go with that for now. I wonder if I should make a note about this somewhere. Probably should. Okay, I'll at least do that. And then maybe I'll remember to look at that at some point. I think once I finish the Mega 2E video, I think I'm going to start a series on like hardware measurements of basically the Apple II, just because there's so many parts of the circuit that I find really interesting. And I just kind of want to understand how they work better. Like, for example, like one of the things I really want to do is show the boot sequence for the Disk 2 controller. I want to capture, in my ideal world, what I want to capture is I want to capture the signal off of the head as an analog channel on the scope, and then show the code. I don't know. I have this picture in my head of what I want to see on the scope, but now that I'm starting to say it out loud, it doesn't make sense. So, never mind. I'll stop talking. Types of power output and power output are connected. So where is power output here? Oh, I might have labeled this wrong. Yep, I made that power output by mistake. Mistakenly. Okay, that's an easy fix. What else we got? Do we have that for anything else? Input power pin not driven by any output power. Oh yeah. So where does this 5 volts come from then? Oh, that's why. Because okay. That's why. All right. So what's happening is the 5 volts is right here, but because there's a resistor for some reason, this node doesn't have a power flag. So then what is this error? Output and output are connected. Yeah, okay. What do we do about that? Okay. Symbol. I'm going to make this passive. Okay. I should have gotten rid of that. Did I not? Oh, I know what I did. I edited the actual symbol. Rookie mistake, James. Rookie mistake. Update symbols. Everything that matches this one now. All right. That should go away. And gone. Yeah, I guess we could have actually used the net tie there. Okay. That's what we should have done. It deviates from the Apple II schematic, but I think that's a better... I would rather have this actually be listed as an output, because I'm confident that it is. So that probably means it's not. Update that, and then what we should do here is do a net tie. There. Because that's basically what that's meant for. So basically net tie just lets you connect two nets together. They're not, they never actually do what you think they do. So, all right. And so this is what RJ was saying earlier, is these all have power units, but in the schematic, they weren't connected to anything. But I think we could make a pretty good guess on what they're supposed to be connected to. So here's what we're going to do. In the power connectors, I'm going to add them in here. So what do we have? Okay, what I should have done. Okay. So we'll put this one here. What was it? It was UB8. So we're going to change it to UB8, and it's going to be unit E. Okay. The next one is UE1. So it'll be UE1. And we'll put this here. Gotta change that back to 1. And then we'll select E. I'll clean these up in a minute. And then what's the next one? This is so annoying. Yeah, okay, I can't fix that. There's this reaction button in the chat window, which I guess is cute, but the problem is it's actually covering up chat messages. So I don't understand why it's there. All right, Squire, have a good night. Thanks for stopping by. Good to see you. I will try to check in on your next stream to see how your project is going. All right. Did I copied that one already? Let's do UC. Well, I can't see it. UC5. All right. And then we'll put that over here. Same story. We change this back to 5. And then we'll select D, which probably is the power. It is. All right. And then UC1. Didn't we already do that? All right. Whatever. I want to try something this time. I'm going to leave here, come back in here. I'm going to do edit, paste special, keep existing reference designator. That's what I want. And then I can change this to C. Okay, let's clean this up now. Yeah, so I was watching, I posted it in the Atoms Discord. What do you call it? So KiCad was last week or the week before. And they, one of the presentations was from Wayne, who is the project leader or project lead. And he talked about what's coming in KiCad 8. And from the sound of it, it sounds like basically 8 is going to, so version 7 had a ton of PCB changes and very little schematic change, and version 8 looks like it's going to have a lot of schematic changes and very little PCB change. But I think what's really exciting is it's basically, I think it's going to bring a lot of feature parity between schematic and PCB. So it seems like it's going to be a pretty exciting update, especially for schematic stuff. Maybe not so much for, PCB, but I can hide it. Is there like, I don't see, I don't know what that does. Go away. That's not what I wanted to press. Yeah, I don't see anything that allows me to, whatever. I'm just going to F12 and delete it next time. Okay. But anyway, yeah, so I think things like the properties panel is going to come into Schematic, and then a few other things like that. But it's just like, yeah, it sounds like they're going to put some attention on Schematic for version 8. Because I haven't kept up with the nightlies. I have them installed in one of my Linux machines, but what do you mean it's not connected to anything? I'm looking at it right there. Oh. Now, wait a minute. How can that be no connect? Oh, because this isn't the 2C. Right? Yep. That's what's going on. The enunciator pins, I don't think exist in the 2C because it doesn't have the 16-pin connector. Duh. And I copied the pin assignments from the 2C IOU, which is different from the 2E IOU, as I explained earlier. So this is actually supposed to be an output, and this is supposed to be an output. So they're called the enunciator. They're basically 3 GPIOs, well, general purpose outputs from the Apple II. And in fact, on my Mega 2E, I used these to blink LEDs. Because why not? If KiCad was owned by Google, it'd be SpyCAD. Okay. I don't even... I mean, yeah, I guess you could argue that about pretty much anything Google. Did I edit library symbol? So, did this not update? Because I feel like this didn't update last time. No, it didn't. That's weird. Whatever. All right. So, ta-da! And there was much rejoicing. Yay. Oh, you know what? I can do it. I know what I can do. I can do this. Where's it at? The more you know, this is fine. Here it is. There was much rejoicing. Yay. There we go. Well, actually what happened is I created a new profile in OBS, and so my Stream Deck buttons are desynced. So I don't have... Yeah. Okay. Yeah, actually ignore the spice stuff. That's fine. Okay, so let's see what our warnings are now. So RP1 has unplaced units. Okay. How many units does it have? Oh, yeah. Well, I think we're just going to exclude that one. MMU has been modified from the library. Okay, let's update it. Any has been modified. Okay, let's update that. Okay. And then sync, both sync and not sync are attached to the same name. Sync will be used. That's not good. They should not be named the same things. Okay. So we are going to actually rename this one, even if it's not the same in the Apple schematic, because this also helps to identify the difference between the Apple II sync and the 6502 sync, which are completely different. This one's video related. The 6502 sync signal isn't used for anything. Unless you have a logic analyzer. Okay, now we have 2 errors, probably because we changed. Yep. Okay, this should be an easy one. Oh, I did. Okay. This is totally, I totally did this one because I did edit library symbol. I didn't edit the library symbol before. So we'll change that, save this, exit this, rerun ERC, that should go away. Now is it warning that it's been modified. Yep. I don't understand why it's not auto updating. I'm missing something. I don't know if I know that one, that demo. I downloaded, so when we got the Mega 2E running, I downloaded a bunch of demos, but I don't recognize that one. So I don't think I know what that one is. Okay. Okay, so then I think I did the same thing here. Is I don't think I changed the MMU correctly. Yep. So we need to do edit. So I need to do edit symbol the library, and then I want to change this one to be an input. I'm going to save this, and then I'm going to update this one, which I thought it was happening automatically, but guess not. Okay, there we go. I'm pretty happy with this actually. So with the exception of that video amplifier, which I would still like to know what the individual signals are, which I will go look it up in the Understanding the Apple IIe book by, is it Sather? The book that at the Kansas Fest I went to, not this year, the year before, the Apple II, Call Apple II guys said they were rewriting it, and I thought it was going to be done by now, and they still haven't finished, which is unfortunate because I really want a copy of the book. Because I think I don't think I have that one in paper form. So, hey, 48K RAM, how you doing? Okie dokie. I'm pretty happy with this. So we've got a redrawn Apple IIe with no ERC errors. This makes for a very, and it's in version 7, so this makes for a very happy James. So I'm going to go ahead and commit it, even though I'm not sure about the video thing, but I mean, I'm pretty happy. So let's go for it. Stage all. Let's see. Updated symbols. Add it. Power symbols for multi-units. And pass the ERC. All right. Happy change. So let's see. I am out of here. So now we will go to this page. Let's do a reload. And I want to compare and pull. Initial. Okay, so I'm going to call this one. Whoa. Okay, update it 2E to version 7 and cleaned up ERC. Pending question on PRAS between MMU and how. Still not clear who drives what, but looks like it goes PAL to MMU. All right. Also, what up with VA1? We'll just do that. You're going to replace capacitors? Aw, that's my favorite thing to do, actually. So I'm actually selling. So I'm finally getting around to selling some of the random stuff I don't need anymore. One of the first things I'm picked were my NES games. So I'll do NES, Famicom. I have tons. I bought like lots of Japanese games. Like the only Japanese games I want to keep are the ones I bought when I was in Japan. So anyway, what I realized though is I'll bet nobody on eBay recaps their cartridges. And so I'm going to be the only person on eBay that does. I mean, it only takes, the downside is the longest part is getting the screws on and off. That's, I wish I had a bit that I could use with my electric screwdriver, but okay. We'll merge this, confirm. All right. And then we should be able to now go to, oh, I forgot to check. Did I say wrong pinout on keyboard ROM? What? N16 is both 07 and CE on the symbol. Oh man. Hold on. Why didn't I catch that? Why didn't I think to look at that first? Where's the ROM at? Is it this one? UE12. So he's saying pin 16 is both 07 and CE. Ah, darn it. Okay, I don't. Tim, look away. I'm going to do something very, very bad. Let's go back to the master branch, which I thought I renamed main. Oh, I haven't renamed it yet. Okay. Let's do a fetch. Pull. All right. And then let's go back in here. Shh. I am not doing what you think I'm about to do, even though I'm about to do it. Push F. See, I don't know if you guys are making jokes or if those are actual Git commands. I cloned the thing again. Yeah. Should have been 18. I'm pretty sure, without even having to look at the data sheet, it was supposed to be 18, right? Because it's 1, 2, 3, 8, 9, 10, 11, 12, 13, 14, 16. Where's pin 17? Damn it. Oh. 2617 wrong. Come out. Okay. 20 is output enable, 18 is. No, what's 17? D7. Did I just miss? Oh. Wait. Wait, what? What the what? Is this not the same thing? 23 76543 9 is goes 9, so 0 1 2. 13 is, wait, 9 is, oh, I see. These are, they did it 1 2 3 4 5 6 7 instead of, so this is actually 6. Oh, right. This is the keyboard ROM. Keyboard ROM is only 7-bit because bit 8 is the strobe. Okay. Whoa, what did I just paste? Okay. Save. Let's exit this. Let's update symbol. Go ahead and rerun ERC just to make sure. Yeah. Exclude that. Close this. Save that. Close this. Close this. And then what was the commit or the error issue number for that? Is that 87? Okay. File status. Only 2E stuff. Wonder why this changed. Whatever. Fixes number 87. Right. Double check. 87. Yup. All right. Commit that. Shh. I did not do that. I did not edit the main branch. I just didn't do that. If you think that's what you saw, then there could be like a setting issue on your computer. Maybe the stream's like in the wrong resolution or something. Okay. So now let's do a fetch. Compression artifact. It's a very specific. You know what this reminds me of is I remember back in the PS2 era. I used to hang out in the pound PS2 on FNet, and people would be like, "I'm having this problem with this part of the game, so I wonder if there's like a scratch on my disc." And it's like if there was a scratch on your disc, it wouldn't load. Period. You wouldn't encounter a bug in the game if this disc was scratched. Like, that doesn't make any sense. Okay. Cool. I didn't actually expect that to go as fast as it did. I'm not complaining, but that's really nice, actually. There is something I want to do that's not related to BitPreserve, but it is a KiCad thing. And I saw it on Reddit, so we're going to try it real quick because I want to see if this is going to work. Because it's very apt to something that I'm working on. Wait, where'd it go? Oh, here it is. So somebody wrote a coil creator. And I want to try out this coil creator. No, so Tim, what you're thinking of is if an asset failed to load. Sure, I could see that being a valid problem from a scratch, but it'd be like I tried to. I was like in Jack and Daxter. It's like I can't do the jump to get to one of the orbs, so I wonder if it's because my game is scratched. And it's like, no, that's game logic. Wouldn't it be messed up? That doesn't make sense. Like that just doesn't make sense. Okay, so let's do a one of these, and then let's go to downloads and do one of these. So we can do one of these, git clone this, or did he have a release? No release. Oh crap, you know what I should have done? We should have made a PDF of the 2E schematic. I don't want to do it right now. I just don't want to do it. That was really dumb though. I really want to. Okay, so how does this thing work? So how to use open main py. All right, so if we go look at main py, let's see, to generate PCB coils from Colton Baldridge. I mean, that's a great name. So name of the footprint, determine if the, okay, so, oh my gosh, this is almost exactly what I wanted. No way. Okay, so I am going to do a pull request and correct his misspelling of KiCad. It should be spelled KiCad, not KiCad. But this looks really close to what I was trying to do. Because there's a YouTube channel, Atomic 14. I think the guy's name is Adrian. I might be wrong. And he did a coil creator, but his code that he shared doesn't work. Like, it straight up has syntax errors all over the place. So it's kind of frustrating because he put together a really nice video, and it looks like from the video it'd be a really useful tool, but he didn't share his actual code. Like, it's not possible. The code he posted just straight up doesn't work. So if this works, this is like really close to what I wanted, where it was like, I just want to give it the parameters and generate a coil. So let's go fire up my KiCad Scratch. It's not Python 2 version versus 3. That it's not like that. It's like literally he like copied and pasted a block of code, and in one block there's like a line that fails, but in the next block it's correct. And so it's like, okay, it's hard to explain. Or the other thing is there's calls to functions that the arguments and the arguments don't match. But in other sections of code where stuff is commented out, they do match. And so it's very clear what he posted was like a work in progress and not the final code. It's not functional code. Anyway, I guess I could just reach out to him. I didn't think about that instead of just bitching about it. Okay. So this is, let's do not symbol libraries, because this is a footprint, but I want to see what he labeled the nodes as, because I think we can just get away with using a coil symbol, which is what I did in mine. I should show what I did, but what I did is stupid. So bald PCB inductors. Yeah, they're stupid. Source. Ooh. Where did... Isn't KiCad mod? Is that not a... Wait, is mod a footprint? I don't remember now. Okay, we'll just do it that way. I guess it's because they're actually footprints and not libraries. Fair enough. But there's no pad. Oh, I see what they did. I guess the idea is I could create my own pad, right? What am I looking for? I'm looking for the pad button. Isn't there like a pin table? I guess not. Why is this already starting at 3 and 4? So what I'm going to do here is I'm going to do this. These are vias, right? Let me double check. They'd have to be vias, right? So this is a plated through hole. What does... But they don't have a pad number. So I guess my question is... What would this be called? A plated through hole. So maybe they just didn't give these numbers. But then why would they have these come out to here? Oh, I see it now. These are the pads, 1 and 2. Duh. Okay. Okay. And then I wonder... There we go. All right. So what I want it to, but see, I knew that when I added a pad and it automatically numbered at 3, like that was really bothering me because I was like, yeah, that should not be. So here's the cool thing. And I think this is definitely in 7, but I think this got enabled after 7.0. You can define net ties so that when you connect copper to these, you don't generate an error. So we're going to save this into here. And then I am going to go ahead and open up my other project, and you will get to see the ones that I made, but the ones I made are bad. I did them like in Illustrator, Livestream. Where did I put PCB inductor trials? Coils? No. KiCad. How does this work? Open up this project. This schematic. Hold on. Oh no, this should have the same library. And then in here, we're just going to add another one of these. And then I'm going to add a ball. Let's go coil, which should show up. Ooh, wait. Oh, duh. Got to change the footprint. This is what I want to. This is what I'm looking for. So we'll do the coil generator. Say OK. Add another one of these. Do a quick wire to here and a wire to here. Bring that there. Save this, F8 to push the changes. Update, close. Yeah, look at that. That's nice. And then I should be able to come over here, and now we can do X to there and X to there. Look at that. Okay. That is cool. I like that. These shouldn't be complaining, but that's okay. I'll worry about that later. Because I think I mostly fixed the DRC problems on mine. Or did I just ignore everything? Yeah. Okay. Cool. I like that. That's now what I would like. I need to understand why this is such a large open area here, but I'll worry about that later. Remote charge joysticks. Yeah. So this is an add-ons video that I'm going to be doing. I have a plan for a PCB based antenna, and I wanted to start with inductors, and then I've got a new LCR meter from Roden Schwartz that I want to use to characterize these inductors. So that's why I saw this on I'll share this this was on the gosh, why is that so lagged? This was on the KiCad Reddit, and it just came up like yesterday, I think. I was like, hey, that's exactly what I want. So cool. That'll be something I play with more later. All right. I'm going to do one more thing. I'm really mad at myself for not doing this. We're going to create the PDF for the Apple IIe. Also, let's delete the old file. In fact, yeah, we'll just delete it. So let's do file, plot. So I think for the PDFs, you want to do plot, because if you do print and then save to PDF, it's basically bitmaps. But if you do plot in version 7, it adds a bunch of very cool little features. I'm just going to say plot all pages. For example, check this out. This I think is so cool. So first, if you click on a net, I thought this jumped to other locations with it. Guess not. But the thing is, you can click on stuff or hover over stuff and get additional information, even though this is a PDF, which I think is just absolutely fantastic. Like, that is, to me, that's like, wow, that's really well done. See, I thought you could, what am I thinking of? I thought you could, or maybe this is what I'm thinking of, is I think if you click on, yeah, so you can use this to navigate the schematic. So I can say, go to this page, and it goes to the page in the PDF. So it's one of these things where, so what happened is I found this when I was doing the Game Gear schematic or the 2C schematic, I don't remember which. And then when I was watching the Wayne update from KiCad last week, he mentioned this and I was like, oh, that's new. I was like, I didn't realize that. So, but yeah, it's just, it's just nice because it's like you get some additional context even though it's a PDF. So yeah, so let's go ahead and close that, close that, close that. And then what I want it to see is how does that show up as the file name? I think I just want to leave the file name as is, because that way somebody else can just come in, click plot, and be done. Yeah, I think we're just going to leave it as that. But I am going to, so in Git, is there a Git RM? Okay, so I want to do Git RM. Oh, come on. Control C, insert .pro. Windows. I guess this is my fault, but whatever. And then I want to do git rm that dot schematic. It's going to complain again. Yeah, I knew there was git mv because I've used that quite a bit. I learned that lesson. I want to say I learned that lesson a long time ago, but it was very recent. Actually, I think we want to delete all the schematic files because everything now is KiCad schematic. So we can do git rm startup schematic. And then what do we have that's .lib? I'm pretty sure we can delete both of these lib files. I'm going to try this. We'll do git rm star.lib. Okay. Why didn't that one get deleted? Okay. I'm missing something. Oh, if it's in the git ignore, it probably does get ignored then, doesn't it? I'll bet it's actually in git ignore. Okay, so now we'll, oh, thanks. That's probably what it was. Let's see. Yep, that's what I thought. Error loading the symbol table, blah, 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 blah. Oh, crap. That's why it errored out. I did it again. For some reason, my computer is defaulting to KiCad 6. I need to just delete it. Okay. Now I probably have to delete files again. But if I do, then yeah. Wait a minute. Something's bothering me. So why is this one? Oh, it is named. I misread it. Okay, never mind. All right, that's much cleaner. So now we'll do another commit to main. Yep. Add it to ePDF and removed KiCad 5 version 5 files. All right. Cool. Okay. Well, that was fun. What am I looking for? Whoa. What? Wait. In studio mode, this looked different for some reason. Anyway. All right. Well, cool. Well, thanks for joining, everybody. Like I said, I think we're going to start doing, we'll go back to maybe doing these every week around this time. And for the short term, I'll be working on bit preserve stuff. So my current goal is I want to get all the existing schematics updated to version 7, and I want to clean up their ERC when I can. So for some of the other computers that I don't know as well, say like the ZX Spectrum, or just any of the Spectrum stuff, or Sinclair, any of the Sinclair stuff, I think the next step is let's just get everything to be updated to version 7 files, clean all that up, and then we can start cleaning up some of the other computers. So cool. Well, thanks for joining. Glad you guys are able to stop by. Appreciate it. And I will see you around the internets. Take care. Now I have to find the fire bit thing. Okay. See you guys later. Bye.